Hello, my name is Matthew Tambaya, and I'm the creator of FastMath. In this video, I will show you how to multiply large numbers mentally without counting zeros in less than 15 minutes. Try doing the calculation 60 million times 3,000 in your head. 3, 2, 1. Do you have the answer? If not, use pen and paper. 3, 2, 1. Okay, time's up. Calculations like this come up frequently in business, where you often need to calculate revenue or profit. Now I'll show you a super fast way to calculate the answer. I started teaching this method in 2013 at leading business schools like Wharton, Harvard Business School, and London Business School, and now leading consulting firms like McKinsey, BCG, and Bain teach this method to their consultants. Watch closely. It will be so fast, it will seem like magic. We're going to write the calculation using the abbreviations M for million and K for thousand. These values are called units of magnitude. So 60 million becomes 60M and 3,000 becomes 3K. K is short for kilo or 1,000. Next, we multiply the numerical portions, which are the numbers that appear before the abbreviations. 3 times 60 is 180. These are just the values before the units of magnitude. Next, we multiply the units of magnitude. What is a million times 1,000? Well, a million times 1,000 is a billion, which we abbreviate with B. That is, a billion is 1,000 millions. And guess what? We just combined these two pieces to get the answer of 180 billion. As I like to say, look, Mom, no counting zeros. And so this method is called no-zero multiplication because we don't count the zeros and we just multiply the units of magnitude directly. We just multiply the numerical portions. 3 times 60 equals 180, and the units of magnitude, million times 1,000 is a billion, and combine these results. We don't count zeros. If you write the calculation with all the zeros, you'd have this: 6 with 7 zeros and 3 with 3 zeros. And most people solve this by counting zeros and find that the final result is this: 18 with a bunch of zeros. Even interpreting this result visually is difficult, as you have to count the zeros to determine the value. If you did so, you'd find the answer is 180 billion, just like we found with no-zero multiplication. But no-zero multiplication gives us the answer in the unit of magnitude directly and incredibly quickly, and is much simpler and more intuitive than counting zeros. Most people need pen and paper to do a calculation like this because they need the pen and paper to write and count the zeros. Once you learn no-zero multiplication, you can do these calculations mentally without relying on pen and paper or a calculator. This is a game changer. In fact, even interpreting a number like this on a calculator can be difficult. So one of the main benefits of no-zero multiplication is that you can do it mentally. Another example: 30 million times 8,000. Using abbreviations, this is 30M times 8K. We have to multiply the numerical portions. 30 times 8 equals 240. Multiplying units of magnitude, what is a million times 1,000? This is the key step. We learned before that million times 1,000 is a billion. So we just combine these two pieces and the answer is 240 billion. It's that simple. Again, this method is called no-zero multiplication because there's no counting zeros. To explain this in more detail, with unit abbreviation, unit name, and unit value. K is the abbreviation for 1,000, which is 10 to the third. K comes from kilo, which means 1,000 in the metric system. And K representing 1,000 is the most important concept in this video. M is for million, which is 10 to the 6th. B is for billion, which is 10 to the 9th. And T is for trillion, which is 10 to the 12th. Each abbreviation is the first letter of the unit name, except K is the abbreviation for 1,000 from kilo. Since we use T for trillion, we can't use T for 1,000, so we use K instead. Now notice that the exponent of 10 increases by 3 with each larger unit value. The exponents are 3, 6, 9, and 12. This means there is a fixed ratio between unit values of 10 to the third, which is 1,000, and which we abbreviate with K, which is called the unit ratio. A quick review of the exponent addition property. 10 to the third times 10 to the third equals 10 to the 3 plus 3 equals 10 to the sixth. That is, when you multiply numbers with the same base, you can add the exponents. These are both base 10, so we can add these exponents. 3 plus 3 equals 6. So 10 to the third times 10 to the third equals 10 to the sixth. 10 to the third is 1,000, which is abbreviated by K. 10 to the sixth is 1,000,000, which is abbreviated by M. So using these abbreviations, we have K times K equals M, or 1,000 times 1,000 equals million. This is the first unit multiplication fact. More generally, 10 to the A times 10 to the B equals 10 to the A plus B. When multiplying values, you add exponents. Now, the exponent of 10 increases by 3 with each successively larger unit. This means that multiplying a unit by 1,000, which is 10 to the third, and which we abbreviate by K, increases the exponent by 3, which takes us to the next larger unit, meaning each unit value is 10 to the third or 1,000 times the prior unit value. So starting at 1,000, which is 10 to the third, and multiplying by 10 to the third, which is 1,000 or K, you increase the exponent by 3 to get 10 to the sixth, which is 1,000,000. Using abbreviations, K times K equals M. Similarly, multiplying 1,000,000 by 1,000 increases the exponent by 3 from 6 to 9, which is 1,000,000,000, which is the next larger unit from million. With abbreviations, K times M equals B. And multiplying 1,000,000,000 by 1,000 increases the exponent by 3 from 9 to 12, which is trillion, which is the next larger unit from billion. With abbreviations, K times B equals T. Essentially, because the exponent increases by 3 with each larger unit value is 10 to the third, or 1,000, or K times the prior unit value. Equivalently, 1,000 or 10 to the third times a unit gives you the next larger unit. When I read an equation with unit abbreviations like this out loud, I will generally say the full unit name. So I will say this as 1,000 times 1,000 equals million. I may read the unit abbreviations as K or M out loud to indicate specifically what is written, or to speed things up in certain situations. But my recommended best practice is to read the full unit name for each abbreviation in most situations. Here are proofs of these equations. First equation, K times K equals M. Using the base 10 exponent for each abbreviation. K is 10 to the third. So on the left, we have 10 to the third times 10 to the third, which becomes K times K. Adding exponents, 3 plus 3 equals 6. So this is 10 to the sixth, which is million or M. So this equation is clearly true. Second equation, 1,000 times million equals billion. K is 10 to the third. M is 10 to the sixth. Adding exponents, 3 plus 6 equals 9, which is billion or B. Third equation, 1,000 times billion equals trillion. 1,000 is 10 to the third, billion is 10 to the ninth. Adding exponents, 3 plus 9 equals 12. So this is 10 to the 12th, which is trillion or T. So these equations are true. To summarize, the main idea is that first, K is an abbreviation for 1,000 or 10 to the third. So get used to seeing K. Next, multiplying a unit by 1,000 or K or 10 to the third changes the unit to the next larger unit, which I call promoting the unit. This is really the main idea behind this entire video, using the definition that K is an abbreviation for 1,000. This follows from the exponent of 10 in the unit value increasing by 3 with each larger unit, and 10 to the third being equal to 1,000 or K. And these are the 3 key unit multiplication facts, so there aren't that many to learn. And even just the first 2 will provide a lot of value, and you should be able to learn these. 1,000 times 1,000 equals million, or K times K equals M, and 1,000 times million equals billion, or K times M equals B. Just these 2 will handle 90% of business calculation scenarios. The simplest way to understand this is that these unit values are just powers of 1,000 or powers of K. The exponent of 1,000 increases by 1 with each larger unit. And again, there is a fixed ratio between unit values of 1,000, which is called the unit ratio. So multiplying a unit by 1,000, which is abbreviated by k, promotes the unit to the next larger unit. 1,000 is k to the first. Million is 1,000 times 1,000, or k times k, which is 1,000 squared. Billion is 1,000 times million. And million is 1,000 squared, so billion is 1,000 to the third. And trillion is 1,000 times billion, but billion is 1,000 to the third, so trillion is 1,000 to the fourth, or k to the fourth. So the unit values are whole number powers of 1,000, or powers of k. Simplifying further, removing the scientific notation column, and simplifying further to just have powers of 1,000 or powers of k, the unit values are just whole number powers of 1,000. The exponent of 1,000 starts at 1 and just increases by 1 with each larger unit. Forget about trillion for now. First, learn that k equals 1,000, and then the two most important facts to learn are that 1,000 times 1,000 equals million, and 1,000 times million equals billion. You'll get a lot of value from just these two facts. Another example, 3,000 times 4,000. This is how I would actually do this calculation. 3 times 4 equals 12, and then 1,000 times 1,000 equals million. So the result is 12 million. And this is how I would perform this calculation with pen and paper. I wouldn't write out the pieces separately as I was doing before. That was just to illustrate the method. I would just write down the results of each piece of the calculation. And so I call this a two-piece calculation. And I use a slightly different method for pure mental calculations, where I multiply step by step. Take the example 60 million times 3,000. For a mental calculation, I would take the whole first term of 60 million and multiply this by 3. And I just multiply the numerical portion of 60 by 3, which is 180, and keep the original unit of million. So this intermediate result is 180 million. This is the first step. Then I would multiply 180 million by 1,000, which was the unit of 3,000, which promotes the unit from million to billion. So the result is 180 billion. Again, this is what I use for mental calculations. I would take the entire first term of 60 million and multiply this by 3, which is the numerical portion, get 180 million, and then multiply this result by the unit of magnitude of 1,000 to get 180 billion. The intermediate result of 180 million had a unit of magnitude. And no-zero multiplication, or multiplying large numbers mentally without counting zeros, is the most important skill for fast math and for mental calculations in business in general. Here's how to learn this. First, learn the unit sequence KMBT. Use the mnemonic kick my big toe. 1,000, million, billion, trillion. Again, K is for 1,000. Once you learn the unit sequence, multiplying by 1,000 just promotes the unit to the next larger unit because the fixed ratio between unit values is 1,000 or K. And we learned these two facts, 1,000 times 1,000 equals million, and 1,000 times million equals billion. We have one more essential multiplication fact. 1,000 times billion equals trillion. And these are the most important unit multiplication facts. In each fact, multiplying a unit by 1,000 takes you to the next larger unit, so just learn the unit sequence KMBT. And one last equation, what is a million times a million? Well, a million is 1,000 times 1,000. So we multiply a million by 1,000 twice. 1,000 times million is billion, and then billion times 1,000 is trillion. So million times million equals trillion. These 4 unit multiplication facts are all you really need to learn. There are a few other things which I discuss in a follow-up video. So that's no-zero multiplication. Now I'll discuss when I use it and the mathematical principles behind no-zero multiplication. If we return to the example of 60 million times 3,000, if you're in a business meeting and you need to multiply these numbers, most people visualize the calculation like this, even if they're doing a mental calculation. And most people need a calculator or pen and paper to do this calculation because they need pen and paper to count and write the zeros, and then to count them again. No-zero multiplication enables you to do this calculation purely mentally without even using pen and paper, and this opens up lots of doors. No-zero multiplication is also really useful in business job interviews, like interviews for consulting, finance, and tech companies, where you can use pen and paper. You can just write out this line with the unit abbreviations rather than writing out and counting all the zeros. No-zero multiplication is much more efficient, especially when you're dealing with lots of numbers. With just a little practice, you can use no-zero multiplication very effectively for pen and paper calculations in job interviews. The first FastMath course actually focused on teaching quant skills for management consulting case interviews, so FastMath was designed for business job interviews. No-zero multiplication makes doing any kind of business calculations with larger numbers a lot simpler with pen and paper. So I do all my pen and paper calculations using the unit abbreviations and no-zero multiplication. Now I'll explain the mathematical principles behind no-zero multiplication. To summarize, no-zero multiplication uses factoring and reordering. The primary concept is that when you multiply numbers, you can change the order in which you multiply them, and the result is always the same. You can also factor numbers and reorder how you multiply the factors. This is used in algebra all the time. I have a video that explains factoring and reordering in more detail. As an example, let's say you have 20 million times 4,000. 20 million is really 20 times million. There is an unwritten multiplication sign between the numerical portion and the unit of magnitude. Similarly, 4,000 is 4 times 1,000 or 4 times k. So this calculation is actually 20 times million times 4 times 1,000. We can reorder terms and multiply 20 times 4 first, and then multiply this by the result of million times 1,000, where these are the numerical portions of the original multiplication terms, 20 and 4, and these are the units of magnitude of the original multiplication terms, million and 1,000, or m and k. 20 times 4 is 80, and million times 1,000 is billion. So the result is 80 times billion, which we write as 80b. Again, there is an unwritten multiplication sign between 80 and billion, or 80 and b. Again, you don't have to write all this out and factor each term explicitly and reorder the terms, but this is what's happening behind the scenes when you use no-zero multiplication. Once you understand the concept behind no-zero multiplication, you can just write down the results of each step. Factoring and reordering explains why we can multiply the numerical portions and units of magnitude separately and combine the results. Here's a proof of no-zero multiplication for arbitrary numbers. Let's say we are multiplying two numbers consisting of numerical portions and units of magnitude. NP1 is the numerical portion of the first number, unit 1 is the unit of magnitude of the first number, NP2 is the numerical portion of the second number, and unit 2 is the unit of magnitude of the second number. So we're multiplying these two numbers. Now remember, we have unwritten multiplication symbols. So these numbers are really NP1 times unit 1 and NP2 times unit 2. So we have this calculation. This is the first number and this is the second number. We can reorder terms and group terms like this. We can multiply the numerical portions first, NP1 times NP2, or the numerical portion of the first number times the numerical portion of the second number, and then multiply this by unit 1 times unit 2, or the unit of magnitude of the first number times the unit of magnitude of the second number. So these are the numerical portions multiplied together, and these are the units of magnitude multiplied together. And when we write this down, we don't write down the multiplication symbol here. We just write down the results of the numerical portions multiplied together and the result of the units of magnitude multiplied together. Note, this result will also be a unit of magnitude. So this is a proof of no-zero multiplication for arbitrary numbers. If you like the no-zero multiplication method, then please like this video. I'm also working on a number of new FastMath videos to teach mental math and simpler ways to perform numerical calculations and solve practical quantitative problems that I think will help a lot of people. So subscribe to the channel if you want to be notified about these new videos, and be sure to click the bell icon so you get all notifications. In addition, please share this video with friends who you think will want to learn no-zero multiplication. And if you want to explain no-zero multiplication directly to friends or colleagues, then please provide attribution to this video and to FastMath. There are also a number of free FastMath business calculation resources. I created a follow-up video on no-zero multiplication, which teaches further ways to simplify no-zero multiplication, discusses the benefits of no-zero multiplication, compares no-zero multiplication to long-form multiplication, and also discusses some additional concepts and nuanced topics that I didn't cover in this video. Link is in the description. We also have an online course called Fast Mental Math for Business, and the basic version is free. This course teaches mental math and efficient numerical calculation methods and covers the most important business calculation concepts and formulas, such as break-even analysis, market sizing, compound growth, and valuation methods. The calculation methods are taught with practical examples commonly arising in business, consulting, finance, and entrepreneurship, and the course covers quantitative interview preparation for these fields. If you work in business or you want to work in business and are preparing for job interviews, or just want to understand how business people approach quantitative decision making, then you should sign up for this course. The basic version is free and includes all the calculation methods. We also offer a professional version which has extensive calculation drills and more detailed explanations and has a 1-week free trial period. All material is available in a self-paced online course with on-demand videos that is accessible at any time and from any place with just an internet connection. Links for further information are in the description. I also created a fast formula sheet for business calculation, which has the most important formulas and equations for business calculation and which is available for free. We'll email this straight to your inbox. Link is in the description. Those resources are all free. If you want to go into further detail on no-zero multiplication or want to practice no-zero multiplication, then sign up for the 2-hour no-zero multiplication and division workshop. Any new calculation method or concept requires a significant amount of exposure to fully understand and extensive practice to fully master. This is a self-paced workshop that uses on-demand video instruction, like this video, to walk you through a simple step-by-step process to learn no-zero multiplication, so that you will be able to use no-zero multiplication quickly and correctly for both mental and written calculations automatically without thinking about it. This is extremely valuable in business and in business job interviews. The 2-hour workshop also teaches no-zero division, which uses a similar method to divide by large numbers, and teaches no-zero division in a similar step-by-step manner. I start with the basics and build your skills incrementally. This course also provides a more detailed explanation of no-zero multiplication and provides further ways to simplify the methodology and thought process, so it covers more material than this video does. I also give you helpful mnemonics so that you can remember how to use no-zero multiplication and division. The course provides you with numerous printable calculation drills with guided solutions, so that you can print these out and practice with pen and paper, which I think is the best way to learn this method, as well as online interactive calculation drills, which are great for practicing mental calculations, so that you can fully master no-zero multiplication and division in only 2 hours. All the resources are provided in a self-paced, on-demand course that is available online at any time and from any place with just an internet connection. I created no-zero multiplication, which is now being taught in leading business schools and consulting firms around the world, and these calculation drills reflect how I practiced and mastered no-zero multiplication. So if you want a more detailed explanation of no-zero multiplication, or you understood the general concept but don't feel like you can use it naturally and want more practice, or you want to learn no-zero division, then sign up for the 2-hour no-zero multiplication and division workshop. Link for further information is in the description. I'm also working on additional fast math resources. If you want to improve your mental math and numerical calculation skills for standardized tests like the SAT, GMAT, GRE, or ACT, or for academic courses, I'm working on a new course called Fast Mental Math for Standardized Tests. So enter your email address to be notified when this course is ready. There will be a free version. And if you're a parent and you're interested in learning how to better teach math to your children or want a mental math resource for your kids, I'll be launching a course called Fast Mental Math for Parents and Kids, and we'll be offering live classes. I have some ideas about how to teach numerical calculation like multiplication and division to children. So enter your email address to be notified about new fast math resources for parents and for kids. Links for each of these are in the description. Here's a little more information about fast math. At fast math, we teach mental math, numerical calculation, and quantitative problem-solving skills for business professionals and for students. FastMath focuses on practical applications of numerical calculation and quantitative analysis rather than theoretical math or proofs like most advanced math classes. We particularly focus on business calculations and quantitative analysis for business decision makers. So if this is something you're interested in, check out the rest of the videos on the channel, as we're always adding new content, and look at the free courses and resources we offer, and sign up for the relevant topic-specific email lists if you want to be proactively notified about new resources. You can also sign up for the general FastMath newsletter and email list. Links are in the description. You can always look at the FastMath website, www.fastmath.net, and the FastMath YouTube channel for the latest information and resources. To give you a little more background on myself and FastMath, the first FastMath course was designed to teach the quantitative skills needed to succeed in job interviews at leading management consulting firms like McKinsey, BCG, Bain, Accenture, LEK, and Deloitte. These are some of the most influential companies in the world. FastMath was the first course of its kind to teach mental math, numerical calculation, and quantitative problem-solving skills for management consulting case interviews, where you need to do extensive calculations and quantitative analysis without a calculator or spreadsheet. This is a challenge for a lot of people. I'm a former McKinsey consultant, so I've been through the interview process and know what quant skills you need to pass the interviews. A big portion of my first FastMath course was efficient numerical calculation methods, what many people call mental math, or how to do numerical calculations quickly and efficiently without a calculator. This was the first course of its kind for business calculations and included many completely new methods and concepts, one of which is no-zero multiplication. A little more information on my background. I'm a former McKinsey consultant, and I have a bachelor's from Harvard with highest honors in electrical and computer engineering and an MBA from MIT Sloan. The first FastMath course was based on a workshop I hosted at MIT for my MBA classmates on quantitative skills for management consulting case interviews. I have another video with more information on my background. I've delivered in-person workshops and live trainings on mental math and quantitative problem-solving skills for job interviews for MBA, PhD, and undergrad students at leading business schools and universities around the world, including Wharton, Harvard Business School, MIT Sloan, Columbia, London Business School, and INSEAD, for both PhD and undergrad students at Harvard and for PhD students at MIT, and for other leading universities. Over 100,000 students and alumni from elite universities worldwide, including all the Ivy League schools, as well as Oxford and Cambridge, have used FastMath online courses and resources to prepare for job interviews at leading consulting, finance, and technology firms. And FastMath students have joined all the leading management consulting firms, such as McKinsey, BCG, and Bain, all the top investment banks, and all the top technology companies such as Google, Facebook, Amazon, Apple, Microsoft, Uber, and Netflix, and leading e-commerce companies. I want to emphasize that FastMath is different from traditional math educational resources. FastMath takes a completely different approach to teaching quantitative problem solving than traditional math educational resources. FastMath emphasizes mental agility and solving problems in the simplest and most efficient way. FastMath teaches practical mental math, one of the most important skills in business, as well as practical numerical calculation and quantitative problem solving skills, whereas most advanced math resources teach purely theoretical math and proofs that don't have real-world applications. No-zero multiplication is just one of the many novel simplification methods that FastMath created and teaches. The emphasis of FastMath is performing numerical calculations in the most efficient way and making decisions based on numerical results and analysis of data. So FastMath should really be called fast calculation. And FastMath emphasizes business calculation, or calculations that arise in managing a business. FastMath has a completely different approach to teaching math and an entirely different curriculum and problem-solving methodology than traditional math courses, meaning that in both introductory and advanced FastMath courses, I cover different problems or solve problems in fundamentally different ways than traditional math courses do. So if this is interesting to you and you want to be notified about new FastMath resources, then sign up for the FastMath general newsletter and email list or one of the specific topics that you're interested in. You can always look at the FastMath website or YouTube channel for the latest information. We also work with companies, career services offices at MBA programs and universities, consulting clubs, and other student career clubs at MBA programs and universities, and schools to teach mental math, numerical calculation, and quantitative problem-solving skills, and to bring a more quantitatively oriented mindset to the entire company or organization. We do this through live webinars and trainings, as well as in-person training, combined with our self-paced online courses, which are available on demand and include on-demand videos. At companies, we can help train your team on mental math for business and quantitative problem solving, and these are topics that surprisingly aren't taught in business school. For career services offices and MBA and university career clubs, we offer quantitative interview preparation workshops and courses for management consulting, finance, and tech interviews. We've worked with a number of consulting clubs at leading MBA programs, as well as career services offices and other student career clubs like finance and tech clubs for quantitative interview preparation. And we host mental math and fast calculation workshops for schools for standardized test prep and general mental math. So if you want me or a fast math calculation coach to deliver a live webinar or in-person training session on mental math and quantitative problem solving for your company, or develop a quantitative training plan for your organization, or host a webinar or workshop for your consulting club, career club, or for your career services office, or give a lecture on mental math for your school, then please get in touch with us. The relevant links are in the description. Again, we can develop a training plan that combines live webinars, in-person workshops and training, and self-paced video-based online courses which are available on demand. We also do one-on-one calculation coaching on mental math and quantitative problem solving for a wide range of people for professional development, academic support, standardized test preparation, and job interview preparation. We work with a very wide range of people, from business professionals and executives to MBA students and graduate students, as well as college and high school students. Doesn't matter where you are in life, we've seen that fast math has been able to help people learn math in a simpler and more intuitive way and dramatically improve their mental math and quantitative problem-solving skills. So if you work in business and want to improve your mental math and understand quantitative business concepts for your job, or you're a current or incoming MBA student and you're nervous about your quantitative skills compared to your classmates, or you just want to improve in this area, or if you're preparing for job interviews in management consulting, business, or tech, or if you're preparing for standardized tests like the GMAT, SAT, or GRE, and you want to improve your mental math and numerical calculation skills, or if you're a college or high school student struggling with quantitative classes and you want one-on-one calculation coaching, then get in touch. The links are in the description. If you want to teach fast math methods or use fast math resources at your university or school, then also get in touch with us. Thanks for watching, and see you in the next video. And remember, keep calculating.